Today I want to talk about resolution of vectors into vertical and horizontal components. Now, the resultant of a vector is a single vector that will produce the same effect as two or more vectors combined together. So every vector has to it vertical and horizontal components. So today I want to explain to you in details how to resolve vector into vertical and horizontal components with acute angles, angle less than 90 degrees. So in other video I will talk about the parallelogram law and the triangle law. So let's start with the resolution of one single vector. Now when we have a single vector, for example a vector acting at angle theta. Now this angle, like I said, it could be an acute angle. An acute angle is an angle that is less than 90 degrees. Okay? So now this is the resultant of the vector. If we form this into a right angle triangle, we are going to have the other two sides. This is the adjacent side and this is the opposite. So we can resolve a vector into vertical and horizontal component using our popular SOHCAHTOA. SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, into vertical and horizontal components by using these two formulas. For example, this angle, let's call this one a vertical component along the y-axis, and let's call this one Vx to stand for the horizontal component along the x-axis. From here, if we use our SOHCAHTOA, so sine theta is going to be equal to opposite, which is Vy over hypotenuse over r. Therefore, Vy is equal to r sine theta. Okay? And in the same vein, we can have cos theta is equal to adjacent, which in this case is equal to Vx over r. Therefore, Vx is equal to r cos theta. Okay? Now, like in when you are dealing with triangles, the Vs and By, depend on the direction of the vector. It may lie on this axis, it may lie on this axis, or on a different axis. Now, this one will lead us to discuss the four cardinal points. But before then, I'm going to use a simple example for a vector that still lies on this plane. I for the vertical component is equal to r sine theta, and for the horizontal component we use what? R cos theta. Now in this case, cos theta is equal to 30 degrees and r is equal to 200 Newton. Here we are picking first as an example of a vector. Please note, it is not compulsory the letter you use, because at some other time you can use just any letter for vertical and horizontal component. What matters is that you actually being able to resolve them into vertical and horizontal components correctly. When we talk about vertical, we are talking about this plane up to bottom, and when we talk about horizontal, we are talking about left to right. Just think across your waist. Vertical is from your hair to your toe, and horizontal is from your left to your right across your waist. Okay? So for Vy, 200 multiplied by 0.5 because sine multiplied by sine 30 degrees, which is equals to 200 multiplied by 0.5, which is equals to 100 Newton. And for Vx, we have 200 multiplied by cos 30 degrees, which is equals to 200 multiplied by 0.866, which is equals to 2. The answer is about 173. The answer is 173.2 Newton. Okay? Now, that is simple enough, right? This vector into consideration. Let's assume you have 20 Newton here. Okay? Now, this angle is 30 degrees. Okay? Now, when you have this vector, notice that the angle is with respect to the vertical, not with respect to the horizontal. Now, for this kind of vector, there are two ways you can solve it. This is 20 Newton, okay? 20 Newton. It doesn't matter. I can write it here, or at the end. It does not matter. What matters is that the line represents the vector. Anywhere I write it, is the value of that. That's the magnitude of the vector. So since the angle is with respect to the vertical, look at what we are going to do. Right? This is your resultant. We can say this is our Vy, and this one will now be what? The Vx. So with respect to this angle, this is the opposite. Vx is the opposite. And Vy is the adjacent. Okay? Vy is the adjacent. Since Vy is the adjacent, you can say from your SOHCAHTOA, sine 30 degrees is going to be what? Opposite over hypotenuse. Opposite. That's Vx over r. Therefore, Vx is equals to r sine 30 degrees. Okay? And we can also say cos theta is equals to adjacent, which in this case is Vy, all over r, hypotenuse. Therefore, Vy is equals to r cos theta, which is in this case is equals to what? This one is equals to what? 20 sine 30 degrees. Let me write it here for clearer view. 20 sine 30 degrees. This one will be equals to 20 cos 30 degrees. So you can see, depending on the direction of the angle, if we are looking at the angle with respect to the vertical, they change. Vy becomes equals to r cos theta, and Vs becomes r sin theta. But if we are looking at the angle with respect to the horizontal, Vy is equals to r sin theta, and Vs is equals to r cos theta. Please take note, it is very often, maybe because of haste or because of lack of understanding, for students to begin to use the formula. Once the direction changes, once the direction of the angle changes, we look at it differently. Another way that you can calculate it is if you must use the same formula of Vy is equals to r, Vy equals to r sin theta, and Vs is equals to r cos theta. you can, from here to here is 90 degrees, so this angle will become equal to what? 60 degrees. You can use this one and get the same answer. Okay, so please take note of this scenario. When you look at it, for the sine of this one multiply by 20, you get your answer. Cosine of this one multiply by 20, you get your answer. And if you interchange it, you are going to see that you have the same answer. Okay, please take note. So when you are resolving vectors into vertical and horizontal components, you are always going to take note of the direction of the angle. Don't just calculate, don't rush it. Okay, now here are two more scenarios for vectors acting in different planes. Now for these single vectors acting in this direction as shown on the board, you are still going to resolve them into vertical and horizontal components, but you must take cognizance into the direction using your SOHCAHTOA. Now this vector has this angle 30 degrees. We have the vertical component which acts along this axis, which we have shown to be what? Sine we have the vertical component Vy and we have the horizontal component Vx. Now for this case, because vector quantity depend on the direction, we are going to look at the angle with respect to the side that is opposite and adjacent. So the formula V is equals to R sin theta and Vx is equals to R cos theta. It's not a constant formula. It changes with respect to the angle. For example, this angle, the opposite is what? Along this axis. So this is the vertical component. This is Vy. And along this component, you have Vx. Okay? For this one, this is Vy again, and this is Vx. Remember, your vertical component is always down to bottom or top to bottom, and your horizontal component is always from your left to your right or your right to your left. Okay? So for this one, theta R is equals to, so for Vy, we have 30 degrees. Angle is equals to 30 degrees. It is not always equals to 30 degrees, mind you. In this triangle, the opposite is Vy. At the adjacent, Vy is equals to opposite. Okay? Adjacent is equals to what? Vs. Okay? So therefore, we can say that sine theta is equals to opposite, which in this case Vy over what? Hypotenuse, which is equals to 50 Newton. Therefore, Vy is equals to 50 sine 30 again, and Vx is equals to 50 cos 30 again. All right, you can work this out to have your answer. For this one, Vy again is also equals to the opposite. It's equals to the opposite. And Vs is also equals to the adjacent. Okay? So we can use the same formula for these three different shapes and direction.